Hi y'all, welcome back to your Unit 4 test review. This video will be number 16 through 28, which is the end. So let's look at 16. We're given a parent function of f of x equals 2 to the power of x, and we're asked to write the equations of these two graphs. So we want to look at the transformations from the parent function. So in order to do that, let's graph the parent function. Y equals 2 to the power of x. That main critical point is 0, 1. 2 to the 0 power is 1. 2 to the first power is 2. 2 to the second power is 4. 2 to the third power is 8. And here is the parent function. Now, in terms of order of transformations, left, right comes first. This graph has moved left 1, 2, 3. Moved left 3. So we'll have 2 to a power of x. That left 3 means we have a plus 3 in the exponent. Yes, that feels backwards. Then this has also been reflected over the x-axis. So that puts a negative sign in front of the function. That reflects every point. So 0, -1, 1, -2, 2, -4, 3, 5, 6, 7, 8. And here is our reflected graph. It's moved left 3 and reflected. And then that hasn't been moved left 3. That's just been reflected. When we move this left 3, left 1, 2, 3, when we move all those points left 3, we are here. Then when we reflect everything over the x-axis, and we see we are here. Now, the last thing we need to do in order to finish getting the graph where it belongs is move that down 1. So this is -1. And here is your transformed function. I'll put these a little better. This is the parent function. This graph here in red has been moved left 3. The yellow has been reflected. Now, do the same thing for number 17. We will look at that parent function. Parent function, 2 to the 0 is 1, 2 to the 1 is 2, 2 squared is 4, 2 to the third is 8, and we settle down on that asymptote at the axis. And here, so we'll go inside, is our function. If we look at our transformations, it is moved right 1. And it has moved up 1, 2, 3, 4. There's no reflection here, so order's a little less important here. That's going to be x to the power of 2 to the x minus 1. And then the up 4 will be plus 4. And there's our function. (18) and 19 want us to list the transformations G, the negative sign, does a reflect over the x-axis. And that minus 5 moves down 5. The base here, base to the power, is 3. So the parent function here is y equals 3 to the power of x. 3 is in the function. It's not a transformation. So let's look at 19. It's a log function. Our base of that log is 2. So its parent is y equals log base 2 of x. That 2 in the base is part of the function. It's not a transformation. Again, the negative multiplied by the function reflects over the x-axis. The minus 6 moves left, right, and it feels backwards. So that moves left 6. And then this plus 4 on the outside moves up or down normal directions. So that is plus 4. And there are the transformations here. Now, starting with number 20, we are going to solve these with the calculator. I'm going to demonstrate this on Desmos because that's what I can get on this tablet easily. So if we have natural log of x equaling negative 4.2, we want to drop and cross. Drop and cross. Natural log is log base e, so that's e to the power of negative 4.2 equaling x. This would be an exact answer. Now, the problem wants this to the nearest thousandth. That's 3 decimal places. So e to the negative 4.2. To get e, we need to go to the keyboard, hit the ABC in the bottom left corner, type the letter E. It knows what e is equal to. You see that number in the box. E to the power of negative 4.2, enter. And rounding that to 3 decimal places, 0.01015. The 9 rounds the 4 up, 0.015. X equals 0.015. This is the approximate answer. Let's look at 21. When we have the variable in the exponent, we want to make the bases the same here. 3 and 5 cannot be made into the same base. So we'll go straight to the calculator, either Y1 on your calculator or line 1 on Desmos. Do 3 to the 2x minus 1, either Y2 in the calculator or line 2 would be 5. And then we will find that intersection point. So line 1, keyboard, y equals 3 to the power of, and we will need parentheses here. What was that? 2x minus 1. Close the parentheses. There's that graph. On the second line, y equals 5. You'll see that intersection point. You can touch it, tap it, and it will give you that x value. That x value is 1.232. 1.232. I'm writing that down wrong, aren't I? Yep, 232. On 22, we have a natural log. To undo a natural log, we drop and cross. The base is e. So e to the power of -3 is equal to what was inside the log, 2x plus 7. Now we just want to isolate that x. So we'll subtract the 7. E to the -3, subtract 7 is equal to 2x. And then we'll divide both sides by 2. And x is e to the -3, subtract 7, all divided by 2. This would be an exact answer. We want an approximate answer, so we'll put it in the calculator. Again, go to ABC. I need a division first. Go to ABC, the keyboard, to get E, then to the power of -3, arrow out of the power. And then we subtract that 7. Then we go to the bottom and divide by 2. Yes. So, -3.475. -3.475. Let's take a look at 24. I'm at 23. What we want by itself first is the natural log term. So we'll divide both sides by 3. And that will give us natural log of 5x equaling 27 divided by 3 is 9. Now we can drop and cross. Natural log drops base of e to the power of 9 is equal to 5x. Then divide by 5. So x is e to the 9th over 5. That would be an exact. And we want an approximate for e to the 9th over 5. So go to the ABC keyboard, e raised to the power of 9, arrow out of the power, then divide that by 5. And to the nearest thousandth, 1620.617. 1620.617. The natural logs don't get very big in a hurry. So to get one to equal 9, it takes a lot of x value. So let's look at 24. We want to isolate here this e to the -x first. So we'll add the 4. So we'll have 3 e to the -x equaling 13. Then we'll divide off the 3. So e to the -x will equal 13 over 3. To get the variable out of the exponent, we'll drop and cross. E as a base drops to log base e, or natural log, of 13 over 3 is equal to -x. So x would be negative natural log of 13 over 3. And that would be an exact. So negative natural log of 13 over 3. Negative sign. To get logs and natural logs, go to the right and go to functions. To scroll down a few blocks worth, get to the ones that say calculus. We're in pre-calculus, it's fine. So natural log of 13 over 3 close the parentheses on that log, and we have negative 1.466. Negative 1.466. Pardon me. And let's look at 25. We have 2 to the power 2.13 to the power of x and equaling 6.3. These are not going to make the same base. These cannot be made into the same base. We really only do that with whole numbers, and even then only whole numbers when they work. So we'll go straight to the calculator on this one. Y1 or line 1 will be 2.13 to the power of x, and Y2 or line 2 will be 6.3, and we'll look at where that intersection is. So y equals 2.13 raised to the power of x. And then on the second line, y2 will equal 6.3. We can see where this intersection is and click it, and it is 2.434. 2.434. Now, let's look at the exponential growth and decay problems. We see our formula here, and we see what everything stands for. So the half-life of a substance is 20 days. Half-life of a substance is 20 days. So remember, for half-life, y sub 0, the initial, is 1. Y sub t, which is the final, is 1/2. K is what we're trying to find, and it decays half in those 20 days. So when we plug into the formula, 1/2 equals 1 times e to the k times 20. That 1 doesn't really matter. We'll drop and cross. Natural log of 1/2 is equal to 20 times k. So that k value is natural log of 1/2 over 20. Natural log of 1/2 over 20 is our k value. Now, for part B, we're using the same half-life. There are 9.5 grams initially, so that's y sub 0, 9.5. When, so it's asking for time, will there be 1.9 grams left? That's the final amount. So this will be 1.9 here. Our k is natural log of 1/2 over 20. So, setting this up, y sub t is 1.9 equal to 9.5 e to the power of our k times t. Now, we do know what k is. It's this equation, natural log of 1/2 over 20. So, pardon me, divide off the 9.5. 1.9 over 9.5 equals e to the power of kt. Drop and cross to solve that. Natural log 1.9 over 9.5 is equal to k times t. K natural log of 1/2 all over 20 times t. So this is looking a lot messier than it actually is. So here's what we want. Okay, we want that natural log of 1/2 over 20. So again, go to functions, natural log of 1/2, close the parentheses on the log, over 20. There's our k value. Now, we don't want to round this decimal, okay? And if you are on a computer, you can copy paste this number on Desmos. If you're on your calculator, you can arrow up to it and hit enter to use it again. So we need the natural log of 1.9 over 9.5. Functions down to calculus. Natural log of 1.9 over 9.5. Close those parentheses. And we need to divide it by this number above. You can probably copy paste this on a computer. It doesn't like working on this tablet. Believe me, I've tried. So I'm going to punch in a bunch of digits here from that value. Basically until the third decimal point quits changing. Okay, so 46.439. 46.439 is what we're looking for here. 46.439 days. And here's what that means. Okay, that half-life of 20 days means we start with 9.5 grams. In 20 days, we have half. That's 4.25. In 20 more days, 40 days, we have half of that. That's 2.125. And in 20 more days, 60 days, that's half of that. So that's going to be 1 point. Why am I blanking on that? Anyway, that's going to be 1 point small number. And so our 1.9 is in between here. So our time is in between here. All right, let's look at 27. A population of bacteria starts at 650, grows by 2.3% per day. How many bacteria would be present after 5 days? So, in order to do this with the percentage increase, decrease, our y sub t is equal to y sub 0 times 1 plus or minus that r, the percentage, raised to the power of t. So we are starting with 650, that's our initial, times we are growing, so it's 1 plus, that r is 0.023, converting 2.3 into a percentage. Move the decimal place over twice, and that will be to the power of 5 because that is 5 days. 5 days. So 650, clear those graphs. So 650 times 1 plus 0.023, close parentheses, raised to the power of 5. And 728.268. 728.268. 728.268 bacteria. Pardon me. On 28, we have enrollment at a small college is 1,500 students, and it's decreasing by 4% every year. We're looking for that predicted enrollment in 10 years. So we'll use the same formula from 27, y sub t, y sub 0, 1 plus or minus r to the power of t. We are looking again for that y sub t, our enrollment later in the future. So initially, 1,500 times 1 minus, because we are decreasing, 4% as a decimal is 0.04. So 1 minus 0.04. And we'll raise that to the power of 10 for 10 years. So putting this in the calculator, 1,500 times 1 minus 0.04, closing that parentheses, to the power of 10, and that is 997 students. And we're rounding this to a whole number because A, the problem told us, and B, these are students, and we don't have a partial student. Did I put that in there right? Yep. All right, guys, that's it for your test review video.